Good morning, everyone. Myself P. Vanitha, working as an assistant professor in the Department of Electrical and Electronics Engineering. Today, we will discuss transducer, one of the fundamental elements in measurement and instrumentation systems. Transducers are devices that convert one form of energy into another, enabling us to measure physical quantities such as temperature, pressure, displacement, sound, and light. Understanding transducers is essential because almost every measurement system begins with a transducer. A transducer is a device that converts energy from one form into another. In instrumentation systems, transducers convert physical quantities such as pressure, temperature, displacement, or force into electrical signals that can be measured and processed. For example, a microphone converts sound energy into electrical energy, while a thermocouple converts temperature into voltage signal. Thus, transducers serve as a bridge between the physical world and electronic measurement systems. Transducers can be classified in several ways depending on their operation and output characteristics. They may be classified based on whether they require an external power, the principle used for energy conversion, the type of output signal produced, and the nature of the measured quantity. The major classification include active and passive transducers, primary and secondary transducers, analog and digital transducers, and transducers based on capacitance, inductance, piezoelectric effect, and photovoltaic effect. One of the most important classifications is active and passive transducers. Active transducers generate their own electrical output without requiring an external power source. They convert the energy of the measured quantity directly into electrical energy. Passive transducer, on the other hand, it requires on external power supply. They do not generate electrical signals by themselves but produce changes in electrical parameters such as resistance, capacitance, or inductance. This distinction is important when selecting transducers for specific applications. Active transducers are self-generating devices. They convert physical energy directly into electrical signals. Examples include thermocouples, piezoelectric transducers, photovoltaic cell, and electromagnetic transducers. Since they do not require external power, they are highly useful in situations where independent operation is needed. The generated electrical output is directly related to the measured physical quantity. A piezoelectric transducer operates on the piezoelectric effect. When mechanical pressure or force is applied to certain crystals, such as quartz, an electrical voltage is generated across the crystal surface. The magnitude of the generated voltage depends on the applied force. These transducers are commonly used for measuring vibration, pressure, acceleration, and sound because they provide quick and accurate responses. Passive transducers require external excitation or power source to operate. They function by changing electrical properties such as resistance, capacitance, or inductance in response to the measured quantity. Examples include thermistors, strain gauges, potentiometers, and LVDTs. Since they depend on external power, the measuring circuit detects changes in their electrical characteristics and converts them into useful output signal. Some measurement systems use both primary and secondary. Some measurement systems use both primary and secondary transducers. The primary transducer directly senses the a physical quantity and converts it into a mechanical signal. A secondary transducer receives this mechanical signal and converts it into an electrical signal. This arrangement improves measurement accuracy and allows easier signal processing. Consider a displacement measurement system. The primary transducer senses displacement and converts it into mechanical movement. The secondary transducers then converts this mechanical movement into an electrical signal such as voltage or current. By combining both transducers, physical quantities can be measured accurately and converted into signals suitable for electronic instruments. Transducers operate Transducers operate based on different physical principles known as transduction principles. Some common principles include capacitive transduction, electromagnetic transduction, inductive transduction, piezoelectric transduction, photovoltaic transduction, photoconductive transduction. The choice of principle depends on the quantity being measured and the desired performance characteristics. Capacitive transducers work by converting the measured quantity into a change in capacitance. The capacitance can vary due to changes in the distance between capacitor plates, changes in the overlapping area of plates, changes in dielectric material between plates. Capacitive transducers are widely used for displacement, pressure, humidity, and level measurements because of their high sensitivity and low power consumption. Electromagnetic transducers operate according to Faraday's law of electromagnetic induction. When magnetic flux changes relative to a conductor, a voltage is induced. These transducers are self-generating and therefore belong to the active transducer category. Applications include speed measurement, vibration sensing, and electrical generator. Inductive transduction converts the measured quantity into change in inductance. This is achieved by moving a magnetic core inside a coil, causing changes in self-inductance. Examples, LVDTs used for displacement measurement. Piezoelectric transduction generates electrical charge when mechanical stress is applied to certain crystals. These transducers are widely used for dynamic pressure and vibration measurements. Photovoltaic transduction converts light energy directly into electrical voltage. When light falls on the junction between two semiconductor materials, electric voltage is generated. Solar cells are the most common example of photovoltaic transducers. They are widely used in renewable energy systems and light measurement applications. Photoconductive transduction is based on changes in electrical resistance due to variations in light intensity. As light falls on a semiconductor material, its resistance changes. These resistance variations can be measured and used to determine light intensity. Applications are automatic street lighting systems, light meters, and optical sensing systems. Transducers can also be classified as analog or digital. Analog transducers produce continuous output signals proportional to the measured quantity. The examples include thermocouples, thermistors, strain gauges, and LVDTs. Digital transducers can produce discrete pulse outputs, usually represented in binary form. These outputs are easier to process using digital systems and microcontrollers. A transducer converts physical quantities into electrical signals. An inverse transducer performs the opposite function by converting electrical energy into physical effects. For example, a loudspeaker converts electrical signals into sound waves, while a piezoelectric crystal changes shape when electrical voltage is applied. Thus, transducers and inverse transducers are complementary devices widely used in measurement and control systems. These references provide detailed information on measurements, instrumentation, sensors, and transducers. They are standard textbooks widely used in engineering education and research. Students can refer to these books for a deeper understanding of transducer principles and applications. Thank you for your attention. I hope this presentation has provided a clear understanding of transducers, their classification, operating principles, and applications in measurement systems. Thank you.